Thank you. All good on the mic? Yeah. All right. Today we'll do some information extraction. We will chain up some tasks, particularly named entity recognition and relationship extraction. We also mostly have named entity linking within this pipeline, but that will be too long for this talk, so I just left that out. But we will get onto it theoretically. I'm Ahmet. You can reach me by that link, and also feel free to join on the coding while getting into the repo there. Also want to thank some colleagues here. They have helped in the content and the models that we ran for this content. Also the data sets. All right. So this presentation is more focused on the task and why we need it, how we formulate it, and how we apply it. And how I want to start on that is by thinking some cases. So let's say we have 3 types of people, and they all have large amounts of text data on their hands. And they want to apply various kinds of machine learning techniques to process that data into a structured format. So let's say there's Tony, and he's a partner in an investment fund. He's doing a lot of due diligence, and he's checking what are these companies up to. Have they been involved in something bad? What events happened with them? Which companies were they involved with? And in our case, Tony is interested in getting information on GameStop. There's also Natasha, who's a researcher working on cancer. So she's trying to skim out these articles on the internet via using some smarter techniques rather than reading them all. There's also Kamala trying to catch up with the competitors on corporate strategy. Again, interested in what their competitors are involved with. Now, as we work these tasks, you can have a feel that these have some similarities between them. So all of these people have some kind of raw text data, and they want to obtain structured information from it. Structured information can sound a bit vague right now. We will get into the details. So, our question is solving each of these individuals' problems, and we are assuming we have raw text data again. Let's say we have obtained some data sources on the internet. These also could be internal resources, to be honest, but then we wouldn't all be familiar with some sources that I would present here. So I'm just coming up with Reddit, Wall Street Journal, and Archive. So after we get our data sources identified, we are starting to get relevant documents from them, because we don't want to utilize all of the archive repository. Rather, we want to query relevant articles. So in Tony's case, it would be GME, and he would query GME within Wall Street Journal to get relevant articles. After we obtain a subset of documents, we are starting to process them, and that is starting via named entity recognition. By entities, we mean particular nouns of interest, like names, locations, dates, organizations, but depending on our use case. Let's say we go back to Natasha. these could be scientific entities, let's say drugs, chemicals, virus types. So we can formulate our entity classes as diverse as we like. I like to imagine entities in a text like nodes in a graph. Say we had different documents and we started to extract some nodes from each of them. So in document 1, we have GME as a company, and we also extracted another company named Apple. In document 2, we have another GME, but that is something different. That's graduate medical education. I just put that as a caveat to see why NEL is important, named entity linking. We will come up to that later. There is an organization named University of Oxford. You can also see two other sets of companies in document 3 and document 4. Next step is in our pipeline to find the relations, the types of relations between these nodes. So one case that we could have is having no relation between them, and that is also a class we formulate into the architecture of our model. If we take the pair of GME and Apple, and I will get into the details of how we do that, and we classify them as a pair into a class, that class could be no relation. Also, that class could be sued, which means either GME sued Robinhood or Robinhood sued GME. You could have different classes to direct the relation. It could be also acquired. Again, you can have direction via diversifying the class. Now, another part that is kind of like magic here is, now check all these GME nodes, please. When I look at them, I can see that this one and the one in document 3 and 4 are actually the same things in reality. They're the same objects, they're the same entities. In document 2, there's something else that is written in the same way, but it's something different. It's graduate medical education rather than the GameStop company. So when we do named entity linking, we cluster or we group these 3 mentions terminologically into one, and we leave the other one out. So now we are starting to have a meaningful graph. Any questions up until now? All right. So in this presentation, what we will cover further is we already did some of the planning, theoretically. We have solved the problem. We have thought about the data sources and task formulation. Now we will get into the details of implementation a bit. I tried to give some ideas on acquiring data and the tasks and serving the results. They will be really basic. So about acquiring some data, after you identify your sources, you either obtain an API access to them formally, or you scrape them. Or you could have already existing internal data resulting from your internal operational processes. You should parse the obtained raw data to a common format, because let's say Wall Street Journal's API and Reddit's API would be different in structure. But if you parse them into a common format, then you can process all of these in sync. After that, we store it. There are a variety of storing options. And you start to query from where you store your data. Okay, we have our data now. We need to process it. We, again, have only the raw text, but it's now parsed in a common format. We will process it, add our predictions to our data store, and we will use that. When we're processing, the first step is to do named entity recognition. How this works is you get the raw text document. Here we have a document that I got from Wikipedia. You use an NER model and a tokenizer. Firstly, you apply the tokenizer to separate your raw documents into tokens. Those are processable units of text. They are mapped to integers, which are then mapped into vectors. And then, inside the model, there are vector and matrix calculations. What we basically do is we classify each token into a class. And then we group the tokens back into words to say this is a 3-word entity, but we want to group it into one object. After we group them back, that's all we have. Some popular models to do NER right now is there is Look, there is AccelNet-based models, and BERT-based models. Look is particularly interesting if you're also into the topic. So we got the nodes now, right? What we need is the relations after that. So a way to do this, a really simple way, is to represent each entity with a vector, then get a tuple of vectors, so a pair of vectors, and classify that pair into a class again. Then we know what kind of relation exists between them. To make it simpler, we have a pair of nodes, and we classify each of them. And what do I mean by the vectors of entities? If you have heard of language models before, you can tokenize your text and transform each token into a meaningful vector, which represents the meaning in a hyperdimensional space. But basically, you can do the same thing for an entity. You can take the average of the, say, 3 tokens here, or more, or you can apply more complicated methods to obtain a vector for your entity. Again, some popular ways to do relationship extraction today is using Luke-based models or Roberta-based models. All right, let's get into some coding. So this is not totally end-to-end, like a tutorial, but it should give an idea on each part and hopefully give a sense of the total pipeline. Firstly, we will get some data, basic scraping, maybe even boring. Then we have the models, and we will parse, save the results, and show them. I'm sometimes having errors with sending the requests to Reddit. But what I'm doing here is basically I have a URL. We could also have a list of those. And I'm using Beautiful Soup to parse, scrape it. I think I'm not connected to the internet now, but I already have the result. Say it here. So after I send the request and get the soup object back, I basically extract the text from each P tag and append it into a list. That's a basic thing I can do. And here are some P tags that I have. I just got the first 7. Now say I scrape the source. What should I do next? I parse it into a common format. This could include IDs. This could include the source ID, source URL that I obtained this from, the date I obtained it, also essentially the content, so the text content within the P tags. Say I have implemented various parsers to parse Wall Street Journal, Reddit, and bioRxiv content into a common format. After that, I need to store it in a shared environment. So what I can do is I can use an Elasticsearch Python client to open an index and post my parsed documents into the index so I can query it later. Here you see my index name, the type of data that I will post, and the content. Say I have applied all this process for various types of data, and now I have a good bunch of data existing in my data store. What I then need to do is querying my existing store to get some documents, to get them into the models. Here, I'm again calling the Python Elasticsearch client, and I'm sending a query with a particular date range, this time on Elon Musk. Let's say we're doing an analysis on Elon Musk, and we're interested in where he goes, where he did go recently. And my query is basically a string named Elon Musk. After I get some articles about this, let's show them to you. So here are under dash separated documents. So this document mentions about some employees getting sacked. This is about Twitter affairs with Elon Musk. But I don't want to read all of these. Rather, I want to apply my models and extract the information. In the notebook, I didn't go into the details of applying the models. If you have been to the previous talk or various other talks, there are open source solutions that you can do these with. So if you use transformers, you can get a NER model tokenizer, NER model itself, put them into a pipeline, apply the pipeline to the article that you have to obtain the entities that we extracted. For relationship extraction, I didn't yet see a pipeline type implemented. So actually, that's a good, I think, opportunity to do some contribution maybe. Or maybe I'm wrong and there is a pipeline existing. Again, if we would have a pipeline, we would get a tokenizer for the loop model, then the loop model itself, put it into the pipeline, and get our predictions. To remind of it again, we are getting entities, entity objects, say a list of dictionaries from the NER model already. Then we need to pair those and pair maybe specific type of entities. So if I'm interested in the visited relation, maybe I shouldn't pair person entities with person entities, because a person visiting another person might not make sense in my use case. So applying that kind of rule-based logic is also useful. After I get my edges of the graph, via applying relationship, extraction, I have some data on my hand. Now let's load that, let's print it, and also let's see a graph of it. So I have just loaded a JSON dataset that has these edges and nodes within. For each document in this dataset, each article, I have objects called visits. These can be none. As you remember, my relation can be of none type. In that case, I'm just not getting those. Also, there is this problem where I have many mentions of the same nodes and also many duplicate relations. So I just get a set. So I have 42 visiting relations now. Here I'm also applying some metadata. So I was interested in getting the article titles. So which event was this relation appearing in? I've also added that basically via linking my nodes to the article title. After I get all of my nodes, I also append another node, which is Elon Musk. Here's how it looks. I'm also trying to parse it into a common format for me to visualize it in a Dash app. So Hornsdale Wind Farms is a location which Elon Musk apparently visited, or our model thinks that he visited it. You can ignore this part. It's just for visualization purposes. Here's how my edges look. So from Elon Musk, there's an edge to the Miami entity, and this relation was found in the article named SAI participated in Bitcoin 2021, blah, blah. Similarly, I have other data points. So what I did right now is I obtained this state. What I didn't do is apply NEL because I already have only Elon Musk as a source entity, and I also applied a set operation to deduplicate the locations. But normally, if I would have multiple people that I'm interested in analyzing, I would need to do some NEL, especially if they have common names between them. So let's dump this data structure that we have and see it in a Dash app. A very basic way to set it up is I implement Dash, I import Dash, then I read the JSON I just dumped. I create a Dash app with some HTML elements. Then I have each relation, each edge, and each node here in the elements argument. Let's run this. Let's make it a surprise and not show this one. All right. You can customize your graphs further, but here's essentially what we have. There's Elon Musk, and we have a bunch of locations. Where graph representations become more valuable is when we have more root nodes, and maybe those root nodes can also have relations between them. So if people would have also relations between them, and if I would have multiple people, just like Elon Musk, then a graph representation maybe would be more valuable than just printing these. So as a summary, we were interested in doing information extraction on raw text. We can imagine this as obtaining relational database content just via applying machine learning models rather than doing manual labor. And we have tried to understand the problems, the use cases that could result in this. After that, we formulated our task in 3 components, and we have seen some implementation in Python to apply each of those. Any questions?
Thank you, Ahmet. Questions for Ahmet over here. There we are.
Hi, thanks for the talk. I had a couple of questions. One related, I think, to the training of the data, right? Of the NER extraction itself, right? So in this case, of course, we're just taking kind of an off-the-shelf model, but probably for most problems we have to do some transfer learning, I guess, right? To train our custom.
Yes.
Okay, and then the second question was more related to the, well, in this case, you were saying, okay, I'm interested in, for example, the an edge labeled visited, for example, right? So is in this formulation of the task, are you using a transformer that has been trained on a question and answer task so that you can parse the full text and kind of ask has this person visited and that's how you kind of get your classification, or how do you actually train that?
A great question, actually. We can formulate it in various ways. So how I mentioned it here was taking a pair of vectors. Let's get into it again. So the mask entity is represented via a vector, and Pretoria entity is also represented via another vector. We are feeding these simultaneously to a model, and the model is applying some attention calculation together with the context fed to classify those into a class. So this is a classifier, our relationship extraction model. And what we do is we feed it each pair and basically get the classes to get the edges. But as you stated, it is possible to formulate this problem as a question answering model. And it is actually something we do internally in our company. So what we do is we have the node fed into a template sentence. Say, what is X? What has X? visited today. And you feed X with various types of people. And for the relation, for each type of relation, you have a different sentence template. So I just structured that sentence so the question answering model would give an answer on the location. But you can have different templates, and when you create training data based on those templates, it starts to work. And that's another way to formulate relationship extraction.
Thank you.
On the first question, though, I think you have asked how we train these models, and do we apply transfer learning. The particular process in that is, so let's say I have an NER model. This would include a pre-trained language model within it, just to get the token embeddings. After that, it would be trained further on maybe a common data set. But what I do later is I could actually annotate some examples by myself and train it further on a couple of hundreds of examples to actually make the model capable in my task formulation and my use case. So that's particularly how we approach on those.
Lovely. Any other questions for Ahmet? Lovely, then we'll call it there then. Thank you very much, Ahmet.